Welcome back, ladies and gentlemen. Without further ado, I'd like to get right into it today. We're going to be dealing with Unit 4 with the theme, The Madness of Fritz Haber. This is a gentleman right over here who did some absolutely incredible things with his knowledge of physical chemistry, as well as some absolutely terrible things. And we'll discuss those in this unit right here. But first, I want to lead you into a little thought game. And that game is, how many drops of water can you fit on a penny? This might sound very simple, but give it a shot, and I think you might be surprised at the actual number of water droplets that fit on a small piece of copper, such as a penny. So go ahead and think about that for a second, write down your response, and we'll get right into the explanation. So, what the heck? What is it that holds those droplets of water in a bubble-like formation on top of a penny? How come they don't just splash over the sides? Or how about this water stride over here? This little insect runs on top of the water. What is holding that insect up and not allowing it to splash right into the water? Or even try this. Put a couple droplets of water on your desk and push them together with a straw or something. What happens when they get close? They suck together. There must be some force holding those together. And that's what we're going to talk about in this lesson. Because, just like Mr. Astor loves Mr. Astor, water loves water. In fact, look what water does in space when you wring out the washcloth. You can wring it out, shake it, and yet it's still going to stay right there. What is that force that's holding that water together? It's something that we experience every day, and it's actually the only reason that we can exist on this earth as we do. So today's lecture is lecture 4.1, Intermolecular Forces and the Dissolving Process. It's going to be very short and very simple, but I want to give you a brief synopsis today. So a few things we want to be able to discuss. We want to be able to discuss how ionic solids dissolve due to random molecular motion of water molecules. We want to be able to discuss how to identify compounds containing hydrogen bonding, dipole-dipole forces, and van der Waals forces, as well as compare and contrast various intermolecular forces and relate them to the dissolving process of a solid. So, first things first. What do solids, liquids, and gases look like? This is something you guys might already know, even though gases are pretty hard to visualize because we can't really see them. I mean, one thing that's pretty useful is you could blow up a balloon. I got a set of balloons right here. If I were to take a balloon out and blow it up, I know that gases exist because this balloon can pretty much flat. Now all of a sudden it's not. What is it? What is it filled with? Entirely filled with gas molecules, which move out randomly like this. We also have some liquids, such as my coffee right here. Clearly, they hold very different properties than their gaseous partners. And of course, solids. Structured, orderly, but still pretty interesting. So, which one of these do you think has the most intermolecular forces between them? Well, let's learn a little bit more about them. First of all, solids. Solids are essentially just substances that have atoms held in a solid, fixed position. However, they're actually vibrating in place due to electron repulsion and other forces causing the atoms to just kind of vibrate where they are. Now, you can have a solid, liquid, and gaseous form of pretty much anything. For instance, water. Water has its solid form, ice, its liquid form, water, and its gaseous form, vapor. And water is actually the only substance that floats on itself. So solid ice cubes will float on liquid water. Probably one of the only reasons we exist as well, because otherwise oceans would freeze from the bottom up, killing all the fish. And we wouldn't have oceans, and probably we wouldn't even exist. So I'm very pleased that water does this. Next up, liquids. Atoms and liquids are a little bit further spread apart. So they're not held in one spot, but they actually move across and around each other, which allows them to fill the shape of whatever container they're in. They flow freely within whatever solution they are, and they move about in a random molecular motion. And then last but not least, we have our good friend gases. And gas molecules are the most energetic. They tend to bounce all over the place. It's like someone took a bunch of bouncy balls, threw them in a giant box, closed the box, and never stopped bouncing around. These atoms are in constant random motion, and that's what allows this balloon to inflate, because all the gas molecules are bouncing off the sides, pushing the balloon to expand. So, Now that when we think about that, we have to realize that gases actually have the least number of forces between them, which allows them to fly apart. And solids are held together by the largest number of intermolecular forces. Go ahead and summarize that for me, and we'll get right into lesson 4.2. I hope this helped.